Hi everybody, this is my presentation for the course project for the Human Factor in AI course. Let's start now with the task analysis by describing the problem. This is the same problem which I presented already in the former two presentation. Here, typical CO2 sensors tend to drift due to several technical factors. Those air quality sensors are primarily used for demand control ventilation in HVAC application. Large drifts, offsets value lead to increased energy demand cost, reduced lifetime and/or lower comfort. A machine learning algorithm may solve those issues. Key task and basic task analysis. First of all, we have to install the sensors, typical for an HVAC system in different buildings. After a while, and once in a while, we make a reference measurement. With this information, we may define a middle value for all sensors, which will be added as an offset into the sensors, but may also be added in a controller. After that, and after a certain while, we may just exchange the sensor because the drift will be too high. And then it starts again from the beginning. That means it goes directly to the installation of the sensors in the building. It is also possible that the owner of the building just accepts the drifts and he does nothing. And then after a certain amount of time, he will just exchange the sensors. This will result in high costs. In the next, I'm showing the simplified task flow, which means after we install the sensors, the algorithms will predict the drift and automatically corrected it specifically for all sensors. That means all above marked tasks will be exchanged by one only task. After that, it is possible that the sensor will also be exchanged, but not because of the drift, because it is just broken. Now let's move to the user experience design. The user interaction with proposed solution. That means in the middle we have the CO2 sensors. The CO2 sensor can interact by wired or wireless connection with a controller, which with a typical HMI just to display values. It can also be connected to a smart device like a phone or a smart tablet. And of course, it may connect directly to the cloud, which information will be used also for other applications. It is also possible that the sensor itself communicates with external sensors throughout the building. That means the temperature sensors, humidity sensors, and other sensors. But those kind of sensors can also be implemented into the sensor itself so that it's not needed to communicate with external sensors. Now to the key consideration of the e-product user experience design. First of all, let's talk about the user inputs. We will collect data from other sensors through different approaches. And further, we will also collect data like attitude, where is the sensor installed, and so on. To point number 2, transparency on the model. Since the prediction varies depending on how many inputs in the systems are available, it has been shown to the user on which inputs the model is based and what other missing inputs may be improved the results. And last point, concerning communicating uncertainty based on the above facts described in number 2, communicate differences of values based on missing inputs. Now some words to the privacy consideration. Privacy-related concerns. CO2 sensors are used worldwide and in different kinds of buildings and applications, like private households, commercial buildings, production facilities, government buildings, etc. Since CO2 value may inform indirectly also about the usage and attendance of those buildings, the data privacy regulation of every region country has to be fulfilled. Further, it may also be possible that some restricted regulation for sensitive buildings like military, etc., may be also considered from case to case. What about the applicable privacy laws and their obligation to us? In general buildings, FIP international privacy policies may be appropriate, but in cases in sensitive buildings like military, etc., we have to consult appropriate described policies of the countries like privacy and security policies of the US Department of Defense, etc. Now, this brings me now to the last slide. We will talk about ethical consideration. Potential sources of bias, there will be two, namely algorithm bias and representation bias. Concerning algorithm bias, due to the other inputs, parameter sources, etc., which may affect the model but has not been implemented and or recognized yet. And representation bias due to the special uses of the building, like disinfection processes, like it is done in hospitals, or chemical processes, like it is done in laboratory, etc. Now to the three goals of ethical: fairness, accountability, and transparency. Concerning fairness, same application and inputs data will result in same outcome. Accountability, the user decides the outcome based on the data that he is willing to make available in the model. He may at any time check the accuracy based on an external reference, measurement, and the model formula. And last, transparency, the user have visibility, respectively decides where the data are used and stored and how the model works based on which data are made available. Many thanks for your attendance and take care. Bye-bye.